Think for a moment of the unseen work that goes into, well, keeping our lives running smoothly.
Hmm.
Clean water from the tap, the air quality in your home, even how efficiently machines make everyday goods. At the heart of all this is something you probably don't think about much: industrial filtration.
Right. It's a fascinating world, actually, with a surprisingly big impact.
And today, we're diving deep into the expertise of Tai zhou Share Filters Co., Ltd. They've got 40 years focused on,
Hmm.
and this is their tagline, industrial filtration solutions to improve the quality of life.
Exactly. So this deep dive, it's really about exploring that intricate world. Filter fabrics, the solutions they build from them. We're using a whole bunch of materials they provided.
Okay.
Their company catalog, detailed specs for specific products like nylon filters, fabricated ones, and even this specialized PPS mesh material.
Okay, let's unpack that.
Yeah.
So our goal today is really to get why industrial filtration is so critical and the sheer variety, the materials, where they're used, and also how customized these things can be. This is basically your shortcut to understanding a field that, well, quietly influences a huge number of industries.
Let's start at the beginning then. Tai zhou Share Filters, they kicked off back in 1983.
Okay.
Started out just as a filter fabrics factory, but what's interesting is how they grew from that, simple start to become a leading Chinese manufacturer, a provider of complete filtration solutions, really.
That's quite a journey. And the range of fabrics now, it's pretty remarkable. You said openings from just 1 micron. It's incredibly tiny.
Yeah, 1 micron all the way up to 4,000 microns. And the materials, things like nylon, polyester, polypropylene, sure, but also stainless steel, PPS, PTFE, even PEEK, for more specialized stuff.
And it's not just the fabric itself, right? They take that raw material.
Exactly. They convert it
Mhm.
into fabricated filters, all sorts of shapes, different configurations, and they do injection molded filters too, custom ones.
So where do these end up?
Oh, everywhere. Home appliances you use every day, cars definitely, irrigation systems, medical equipment, food and beverage industry, electronics manufacturing,
Yeah.
even aerospace. It's a really broad range.
You mentioned their vision, something about improving quality of life.
Yes, their stated vision is to be an innovative and reliable filtration solutions manufacturer to improve the quality of life. And you see that echoed in their mission.
Which is?
Basically, providing the best filtration solutions and superior customer service, the aim. Improve lives, enhance equipment performance, and importantly, protect the environment. It's, well, quite compelling to see a company lay it out so clearly.
Yeah, it is. And they list values too.
They do. Things like honesty, integrity, innovation, sustainability, customer obsession, that's a strong one, quality excellence, teamwork, collaboration. It really seems to underpin how they approach things day to day, connecting back to that bigger vision.
Okay, so where does all this happen? The manufacturing, the innovation?
Mhm.
Sound like a pretty big operation.
Well, their main base is in Tiantai, in Zhejiang province. Apparently, it's known as the hometown of China's filter cloth, which is quite fitting.
Huh?
And they've got a vertically integrated setup, 3 main parts. A textile plant for making the filter materials, a machining plant for the fabricated components, and an injection molding plant. All told, it's around 12,300 square meters.
That's a decent footprint. Suggests they've invested quite a bit in their tech.
Absolutely. They mention over 200 sets of advanced looms and machinery, things like high-precision Swiss Sulzer looms, Benninger warping machines for prepping the yarn,
Right.
plus laser cutting, ultrasonic welding, injection molding machines, both vertical and horizontal. And this vertical integration, it's key. It gives them control over the whole process. Quality from the mesh right to the finished filter.
And why is that level of control so important, especially in filtration?
Because precision, consistency, they're absolutely everything in filtration. Their whole process emphasizes customization for specific needs, full traceability so you know where every part came from, reliable performance you can count on, and really tight lot-to-lot accuracy.
Right.
Think about it. If a filter's in, say, a medical device, you need absolute certainty every single one performs exactly the same. No variations.
Makes total sense, especially for industries like healthcare or aerospace with those really strict rules.
Yeah.
What kind of production volume are we talking about annually?
The numbers are pretty big. Over 5 million square meters of filter mesh material, 10 million fabricated filters, and 8 million molded filters each year.
Wow.
Yeah, it gives you a sense of the scale they're operating at for global markets.
With that kind of output, keeping quality high must be, well, a major focus.
Oh, definitely. They have a multi-stage quality control system,
Yeah.
very rigorous. Starts with operators doing self-checks during production, then dedicated QC teams do spot inspections, and finally, comprehensive final inspections.
How do they do those checks?
A mix of methods, visual checks, optical inspections, but also more advanced stuff like pressure-sensitive tests and even automated 3D image analysis. They really want to ensure every product hits their standards.
Okay, so a company that's been around 40 years, they've seen a lot of changes, I bet. Technology, market demands. How do they keep up? How do they stay ahead?
Innovation. It seems absolutely central to what they do. They reinvest 20% of their profits back into R&D every year. That's significant.
100% is a lot.
It is, and it's not just about new products. They focus on improving their company culture and management, too. They seem to get that continuous improvement is vital to stay competitive.
And with 4 decades just focused on weaving these fabrics, they must really understand that process inside out.
Oh, definitely. That weaving expertise is a huge advantage. They understand how different polymers, yarn thicknesses, weave patterns, how they all interact to get specific filtration results. They control things meticulously. Mesh opening size, the percentage of open area, threads per inch, yarn diameter, the fabric thickness, every step.
So it's not just the material, it's how you build the fabric at that tiny scale. That's critical for how it performs.
Precisely. And their weaving capabilities cover that huge range of materials we mentioned. They can make fabrics really wide, too, up to 3.9 meters in some cases, depending on the material and what it's for.
And the mesh openings again?
From that super fine 1 micron for really precise jobs up to 4,000 microns for, coarser stuff.
Okay. And then comes turning these fabrics into actual filters, the converting process. What technologies do they use there?
They have a really comprehensive toolkit for that, different cutting methods, like cold cutting, which is often cost-effective for simple shapes. Heat cutting seals the edges, stops fraying.
Right.
Then there's ultrasonic slitting and welding. That gives you very clean, strong seams, tight tolerances. Laser cutting lets them do really intricate shapes, also with heat-sealed edges. And, of course, injection molding to make 3D filter parts directly.
It's lots of options.
Yeah, it lets them take that base mesh and really transform it. Make it colored, coated, heat-treated, shape it with pleats or seams, or mold it right into the final part. Very specific solutions.
Okay, so we've covered the company's background, their capabilities. Let's dig into the products now, starting with those precision filter mesh fabrics, Chapter 1 in their materials.
Right. So these precision meshes, they're made by weaving warp yarns and weft yarns at right angles. Simple idea, but it creates very consistent square openings across the whole fabric.
And the materials?
Lots of synthetics, different nylons, polyester, polypropylene, polyethylene, metallic options too, like stainless steel, brass. And they also mention other specialized fabrics and felts for specific jobs.
The micron rating, the size of those holes, that's obviously key. What's the range again, and what else matters about these fabrics?
Yeah, the range is 1 micron up to 4,000, very fine to quite coarse. They use both single-strand yarns, monofilament, and multi-strand yarns, multifilament. And different weave patterns too. Plain weave is the basic over-under. Twill weave creates a diagonal pattern, often stronger. Dutch weave is denser, often used for finer filtration. Each pattern gives different properties, different flow characteristics.
So what are the big advantages of using these precision mesh fabrics? Why are they good for so many different things?
Several key benefits. You get really consistent yarn diameter, which helps make the opening size precise. The tolerances on those openings are super tight, so the filtration is consistent. The surface is smooth, which helps prevent clogging. They hold their shape well, good dimensional stability. Thickness is controlled down to the micron level. Plus, they're clean, production is repeatable, and they can offer food-grade or medical treatment options if needed, or supply them without any chemical treatments at all.
That level of precision at the micron scale is pretty amazing to think about. And where do these basic mesh fabrics actually get used?
Oh, the applications are incredibly diverse. Everyday home appliances, definitely. Automotive, lots of fluid and air filters in cars, irrigation systems, hydraulic equipment.
Medical, too.
Yeah, medical devices for filtering liquids, gases, food and beverage industry for processing, purification. Electronics manufacturing needs clean environments, even specialized aerospace uses. Really broad.
Okay, their catalog has detailed technical data. You mentioned nylon, polyester, polypropylene.
Yeah.
For someone trying to pick the right one, What are the key differences? What stands out?
Right. This is where material properties really matter. Take nylon filter mesh, usually PA6 or PA66. It offers good stability, very precise openings, smooth surface, it's strong, elastic, holds up well to abrasion, good resistance to alkalis, some chemicals, fuels, solvents. The key thing with nylon is it absorbs more moisture compared to, say, polyester. That can be a factor.
Ah, right. So wet versus dry environments would make a difference there. What about polyester, its strengths?
Polyester mesh made from 100% polyester yarn. It's known for excellent dimensional stability, accurate openings, smooth surface again, resist tearing well, high tensile strength, good air permeability.
And chemically?
Importantly, polyester resists a wide range of chemicals, including lots of acids and solvents, good temperature resistance too. And a key advantage, low moisture absorbency. Makes it great for humid or wet conditions where you need consistent properties.
Okay, so nylon might be better for flexibility or certain chemicals, but polyester wins on moisture resistance and maybe broader chemical stability. What about polypropylene?
Polypropylene mesh, again, 100% PP yarn. It's really notable for how well it welds. High resistance to hydrolysis doesn't break down easily in water, and excellent chemical resistance biological agents, alkalis, mineral acids, organic acids, oxidizing agents, plus basically zero moisture absorbency.
So polypropylene sounds like the tough choice for really harsh chemical environments or constant liquid exposure.
It's a very robust option, yeah.
We also heard polyethylene and stainless steel mentioned earlier.
Yeah.
What are their key features for filtration?
Polyethylene mesh is often picked because it's lower cost. It also has good resistance to acids and bases and various solvents, performs well at low temperatures too. Sometimes it's used as a cost-effective alternative to PTFE in some chemical or pharma applications.
And stainless steel. Sounds premium.
Stainless steel mesh grades like 304, 316, 430 offers exceptional mechanical stability, very high strength, consistent openings, and excellent resistance to acids, alkalis, corrosion, and high temperatures. Resists wear, too. The different grades, like 316L, have slightly different compositions, tweaking properties for really specific, demanding jobs.
It's really clear that picking the right material depends heavily on the specific job, the environment, what's being filtered.
Okay.
Now let's move to Chapter 2, fabricated filters. This is taking that mesh and making actual parts, right?
Exactly. Fabricated filters mean taking that precision mesh and processing it further into custom shapes, custom forms, exactly what the customer needs. Things like stamped shapes, discs, ribbons, tubes, pleated elements to get more surface area, filter bags, lots of possibilities.
Even multiple layers.
Yeah, they can do multi-layer configurations, tubes or ribbons, often needed for more complex filtration tasks, or sometimes they're used in insert molding processes later on.
And they have different ways to make these fabricated parts.
Yes, a whole range of fabrication tech. Ultrasonic slitting and welding that gives clean, sealed edges, very tight tolerances, good for widths from just 1 millimeter up to 400 millimeter.
Okay.
Heat cutting and slitting uses heat to fuse the edges, stops fraying. Suitable for wider stuff, 10 millimeter to 1800 millimeter. Laser cutting gives you almost unlimited freedom in shape and size, again with clean, heat-sealed edges.
And simpler options.
Cold cutting, stamping, punching. More economical ways to get different sizes, but the edge isn't sealed. And finally, sewing. That's used mainly for custom filter bags for all sorts of applications.
So depending on the precision needed, the material, the end use,
Right.
there's a specific technique that fits best. What's the advantage of getting these fabricated filters instead of just buying the mesh fabric?
Well, several things. First, you get their expertise. Advice on the best material, the best processing method for your specific need. Second, the shapes and sizes are pretty much unlimited. They can use food-grade materials, provide traceability if that's needed, and depending on the method, you get those sealed, non-fraying edges, which is really important for the filter's integrity and performance over time.
Where would we typically see these kinds of fabricated filters being used?
Again, a huge range of industries. Automotive, filtering fluids and air in vehicles, healthcare and medical devices and procedures, industrial equipment for process filtration, even common household appliances.
Any specific examples?
Sure. Laser stamped shapes for really intricate needs and sensitive equipment, ultrasonic welded discs in fluid systems, mesh strips or ribbons for sealing or filtering in tight spots, multi-layer tubes for complex separation, pleated elements, more filter area and less space, tube segments for flow control and medical uses, biopsy bags for surgery, sewn rosin bags for extraction, and loads of different liquid, custom, and needle felt filter bags for industrial processes.
Okay, moving to Chapter 3, molded filters. This sounds like where the mesh meets plastic injection molding expertise. How's that work?
Exactly right. This is a real strength for them, integrating their industrial mesh with their technical manufacturing skills. It results in highly precise, often very cost-effective filter solutions.
And fully customizable.
Yeah, customizable size, shape, the type of plastic they use, even the color. Lets them meet really specific performance needs and integration requirements for whatever product it's going into.
And these molded filters, they need to handle tough conditions sometimes.
Oh, absolutely. They're designed for all sorts of media: water, fuels, oils, cleaners, chemicals, paints, air, gases, even vacuum systems. They use horizontal and vertical injection molding machines.
What plastics can they work with?
A huge range of thermoplastics, common ones like PE, PP, POM, ABS, nylon, with options for fiberglass reinforcement to add strength or rigidity. They also do insert molding, putting the mesh in the mold first, and molding plastic directly onto other parts.
What are the big advantages here? The core is still the mesh fabric, so what does the molding add?
Well, molded filters give you an optimized design for the specific use, often with very tight tolerances. And it can be really cost-effective, especially if you're making a lot of them.
Right, volume production.
Exactly. Plus, you get access to that huge range of plastic materials for specific chemical or temperature resistance. They offer high stability, consistent performance, great reliability, and they provide support, expert advice on materials, colors, technical consulting on the design, rapid prototyping to test things out, even help with assembly and installation.
It's very comprehensive, integrating the filter function with the structure and material benefits of molding. Where do these molded filters typically show up?
Again, super broad, many home appliances, automotive systems, lots of uses there, irrigation equipment, clean water delivery, hydraulic systems, chemical processing plants, mineral extraction, food and beverage industry processing, packaging gear, healthcare, medical devices, electronics manufacturing, even acoustics for dampening, and milling processes too. It's extensive.
Their catalog, you mentioned, has a big list of housing materials and compatible meshes. And that chemical resistance chart sounds like a gold mine for engineers.
Oh, that chart is packed with info. It breaks down how all sorts of different polymers handle exposure to acids, alkalis, organic solvents, alcohols, fuels, even gamma and UV radiation. It lets engineers really pinpoint the right material for the exact conditions the filter will face. And yeah, they list a ton of housing materials from ABS and PP up to high-performance stuff like PEEK and PTFE, and they clearly show which of their mesh materials, nylon, polyester, PP, stainless steel work with each plastic, and what micron ratings are available for those combinations.
It really highlights their technical depth, the sheer number of options they can offer for very specific problems.
Yeah.
Okay, let's talk about their overall filtration solutions, Chapter 4. This sounds like where it all comes together.
Exactly. This builds on that 40 years of experience with all those mesh types and components. Because they're vertically integrated, they can offer true end-to-end solutions. They manage everything, from making the filter fabric initially to creating the fabricated parts to manufacturing the injection molded components, all while keeping tight control on quality, cost, and their supply chain.
So they're not just selling parts, they're providing complete answers to filtration challenges.
Precisely. They really emphasize their ability to meet both general needs and highly specialized ones. Areas like water purification, separating solids from liquids, air filtration, various industrial processes. They have apparently developed thousands of custom solutions across all those industries we mentioned: appliances, electronics, medical, auto, food bev, mining, architecture, aerospace.
And they help customers figure out what they need.
Yes, they have application specialists who work directly with clients to design, manufacture, and implement the best filter solution for their specific, unique requirements. It's that combination of deep manufacturing know-how and a consultative problem-solving approach.
That seems key. Now, let's zoom in on one specific material they highlighted: PPS mesh, polyphenylene sulfide. Sounds specialized.
Yes, PPS mesh is made from 100% PPS monofilament. It's particularly valuable for energy and environmental applications because it has some exceptional properties.
Like what?
Very high corrosion resistance, excellent thermal stability. It melts at 285 degrees C and can be used continuously up to 190 C, and it's inherently flame retardant.
Wow. Great.
Plus, it resists hydrolysis really well, even at high temperatures, and it stands up to a wide range of acids, alkalis, and organic solvents.
Those are some serious performance specs.
Yeah.
Especially for tough environments. What are the benefits and typical uses for PPS mesh?
Key benefits include, well, relatively affordable cost for its performance level, a uniform structure for consistent filtration, high porosity, so good flow rates, and a large surface area for efficiency.
And application.
Makes it good for things like ion exchange processes, alkaline water electrolysis for hydrogen production, which is a big growth area right now, feed and food drying, filtration in food, semiconductor, chemical industries where purity is critical, as a support structure for catalysts, oil water separation, gas filtration and purification, wastewater treatment, air pollution control, even desalination.
So really targeted at demanding industrial and environmental jobs, where things get hot or chemically aggressive. What options do they offer in PPS mesh?
A range of specs, thread diameters from 30 to 250 microns, mesh counts from 25 up to 420 threads per inch, openings from 30 to 800 microns, open area between 25 and 60%, thickness from 56 to 508 microns, available in plain and tool weaves, widths up to 3 meters plus customization.
And they provide data.
Yeah, their tech data sheets give specifics for different PPS mesh types, including options using high-quality Toray yarn, details on diameter, opening, area, thickness, weight, and importantly, tensile strength and elongation properties.
Mentioning Toray yarn suggests they're focused on quality raw materials, even for these specialty items. Okay, finally, let's talk about customization and support. Sounds like a big part of their offer.
It really is. They emphasize a huge range of customization options, not just for the mesh rolls, but for the fabricated and molded filters too. Materials, micron ratings, dimensions, shapes, the specific manufacturing tech used.
And they work with the customer.
Very closely. They stress partnership, working together from the initial idea through design, manufacturing, even installation, to get a filter solution that perfectly fits the customer's unique operational needs.
And the support doesn't stop at just selling the product.
No, it's comprehensive. Their application specialists offer technical help figuring out the right specs, validating the design to make sure it performs as needed. They have a global supply chain, different packaging, shipping options for international clients, and importantly, they readily provide samples and ongoing technical assistance.
Okay, so let's try and synthesize the key takeaways from this deep dive into Tai zhou shear filters. It's pretty clear they bring, well, a ton of experience. 40 years is a long time. A really diverse range of materials and manufacturing capabilities, and a strong commitment to both innovation and quality in this field of industrial filtration.
Yeah, and that expertise has a huge impact
Yeah.
across so many industries, many we probably don't even think about consciously.
Absolutely. And for you, the listener, hoping to get them to speed quickly, this deep dive has hopefully shown just how complex and how critical industrial filtration really is in our modern world.
Right. The sheer variety of uses, the level of material science and engineering involved. It really highlights how foundational this field is, maybe provided some of those aha moments we always aim for.
It definitely underscores how many hidden technologies are just essential. Essential for our daily lives, for industry to function smoothly. So maybe the next time you see a filter could be in your coffee maker, your car, maybe even in a hospital setting. Will you look at it a bit differently now, with maybe a bit more appreciation for the intricate engineering and the clever material science that went into making it? That's certainly something to ponder.